Hello everyone. In this short video I want to talk about unrestrained or degenerate systems. Here we have a 3 degree of freedom system and no damping, so it has sustained oscillations. And if we draw the free body diagrams and write the equations of motion, these are the equations of motions that you can see on the left side. And here you can of course write it as mx double dot plus kx equals 0, where M matrix is this one and K matrix is that. And I'm going to plug in the numbers I have considered here into the matrices, so you get the two matrices M and K, as you can see. And then I formed the matrix M inverse K. If you remember from my previous videos, the matrix was what? The matrix that we found all of the eigenvalues and eigenvectors. It was M inverse times K, so I formed that matrix. And then I used the ig command in MATLAB to get what? The eigenvalues and eigenvectors. And if you look at the eigenvalues and eigenvectors, you see something interesting. So these are the three eigenvalues and the square root of the eigenvectors and the square root of eigenvalues, or the natural frequencies basically, right? And these are the corresponding eigenvalues. And you see one of them is interesting. The first one, if you look at that, the natural frequency of the first mode is 0. And the displacement between the three masses, they have all the same displacement. They are all 1 over square root 3. What does that mean? When you have 0 frequency and all masses move together, right, the same amount, this is what we call a rigid body motion, right? This is a what? This is a rigid motion. There is no vibration here. Okay, this is a rigid motion. There is no, as I said, vibration. Because vibration happens when the mass of the system, the masses of the system, they move with respect to each other. There is relative motion. Some get closer to each other, some get further away from each other. If they all move the same amount, so that means all these three masses, they move all to the right or they move all to the left together as like one single rigid body. Why is that happening? Because the system is not restrained. None of these masses is attached to a wall. If this guy was attached to a wall with maybe an extra spring here, or this guy was attached to the wall with a spring, or at least this middle one was attached with a spring to some wall or something, then the system could not freely move. Okay, but in this case, none of that is available here. The system is allowed to completely move to the right or to the left. And if that's the case, then the system, one of the modes of the system will show that. So this system is what we call what? Unrestrained system or degenerate system, where you have one frequency of 0. Remember that in vibrations, we are talking about deformations. In dynamics, we are talking about displacement. So let me write it for you. So vibrations is about deformations. Dynamics is about displacement. And what you can see here is your first mode shape is showing a dynamic behavior. The other two modes are showing what? Vibrations. The masses of the system are moving relative to each other. And so you'll get what? You will get some relative displacements. And another interesting thing is, it's not related to the topic of this video, but if you can see, the first mode shape has one node. There is one place here with 0 displacement. The second mode shape has 2 nodes. So as the mode shapes progress and you get basically higher mode shapes, then you get more and more nodes, as I showed you with the string example in one of my previous videos. So just wanted to tell you that if you ever see, if somebody gives you, without giving you the physical system, so you don't see the physical system, but somebody gives you some M matrix and some K matrix and say, hey, is this system capable of completely moving, not deformation, just entirely moving to the left or right? Is this system capable of doing displacement? All you need to do is to basically get this M inverse K matrix, find the eigenvalues and eigenvectors, and if you see any eigenvalue of 0 or any eigenvector with all elements equal, that means the system has not been properly what? Restrained, and it's actually capable of moving. Just wanted to clarify that for you in this video, so hopefully it was useful to you, and I'll see you in the next video.